You might have heard people say, if you're not part of the solution, you're part of the problem. Well, in chemistry, we say, if you're not part of the solution, you're part of the precipitant. And if you don't know what that joke means, hopefully by the end of this lesson, you will understand what I mean by that. So what is a solution? You are surrounded by solutions every day. My personal favorite here is tea, or you've got hot chocolate, or some coffee. And what you see here on the left-hand side is a molecule, which is the caffeine inside of each of these liquids that you see on the right. So within a solution, we have two main vocabulary words to talk about. The first one is a solvent, where the solvent is the main part of a solution. It's the one that does the dissolving. So if you think about how you brew a cup of coffee, you place the coffee beans on the coffee filter, then you turn on the coffee pot. Well, with a coffee pot, you're dissolving parts of the cocoa, or the coffee beans, if you will, into your beverage below. And so it's the water that's doing the dissolving. So in that case, your solvent is water. It's also the biggest component. So no one would argue that, there's more caffeine than there's water, because there's a whole bunch more water than there is caffeine. So instead, the solute is the caffeine, that's your cream, that's your sugar, that is all the other components that are in small parts, whereas the solvent is the main component of the solution. And the precipitant is if you have something that solidifies in the bottom. It's no longer part of the solution. It is in fact just floating. It's part of, it's solidified, so it's the precipitant. In chemistry, molarity is how we can express concentration. So if I say how concentrated is something, all I'm asking is how much of the solute is present in a given amount of a solution. So as this little figure 8 on the left side is trying to demonstrate, is molarity is just saying how many moles do we have per liter. And every previous video has taught you how it is that you turn grams or molecules into moles, and once you have it in moles, then it's as simple as dividing by your volume. And if you have moles divided by liters, that is considered molarity. Now you can express concentration in many different ways, but molarity is the most common way of expressing concentration for chemistry. You also have other things such as parts per million, that kind of thing. But this is the most common, so this is what we're going to look at today. So let's do an example together. The question might look something like, what is the concentration of a solution made by dissolving 5 grams of sugar into 2 liters? So in this case, we're going to convert grams to moles. That's your first step. So we have 5 grams. And remember, we've got these two conversion factors here to choose from, where if our sugar is C12H22O11, you already know how to calculate the molar mass of this, and that's 342.30. So now we have these two options. What you want to do first is put 5 grams, which comes from the problem, out front. And now if we want grams to cancel and moles to remain, that means we want grams as the denominator and moles to be the numerator. So we can multiply this across, leaving us with the number of moles that are present. Then we need to divide by the volume in liters. So in this situation, you just simply take those moles and you place it over the total volume, which is 2 liters. Do that math, 0.015 divided by 2, and you end up with 0.0073 molar of sugar, sucrose. Let's try another problem. What is the molarity of a solution made by dissolving 32 grams of sodium chloride into 500 milliliters? So the first step is the same. You need to convert grams into moles. And so if we start out with, just as the previous problem did, with 32 grams of sodium chloride up front, and then we use whichever conversion factor will lead us to having moles of sodium chloride on the other side. So in this case, we want it to be 1 mole of sodium chloride over 58.44 grams. That way the grams cancel out and you're left with moles. Now we know the number of moles, so now we just need to divide by the volume. But the thing is, our volume needs to be in liters. So if we have 500 milliliters, in order to convert that into liters, remember 1,000 milliliters are in every liter, and that gives us 0.5 liters. You can also move that decimal point 3 to the left. And now we just divide. 0.548 moles of sodium chloride divided by 0.5 liters gives us 1.10 molar sodium chloride. Next, what if we have a question like this that's opposite? How many moles are in 0.5 liters of 5.6 molar sodium chloride? It's the same equation. Molarity equals moles per liter. If that's a true statement, then this is a true statement. We just multiply both sides by liters, making it so moles equals molarity times our volume. So molarity is 5.6 molars, volume is 0.5 liters, so what does our moles equal? All you do is you take 5.6 times 0.5 to give you 2.8 moles.